So in this video, we are going to start talking about what we call a phase shift and a vertical shift for our sine and cosine functions. So when we are talking about a phase shift, this is a horizontal translation. So that means that our graph is going to be shifting either to the left or to the right. And in our equation, we're going to be using h to identify this. Okay, so as you're looking at this picture, this graph is shifting over to the right. Okay? And then when we're talking about this vertical translation, that means that our graph is going to shift either up or down. And we are using k in our equation to represent that. Okay. Now, all the other transformations are still the same. So as we look at our equations, the a is still in charge of the amplitude, which affects the height of our wave shapes. And then if this is a negative, that means that a reflection happened. So for the sine function, if we're thinking about this, instead of going up first, we would start down first. And then for cosine, normally we would have this U shape. So if a reflection happened, then it's going to open up like this. Okay, so that part is still the same as before. Our b is still in charge of figuring out the period, which is how long one of our cycles is. So if it's in radians, we're using this 2 pi over b to find that. If it's in degrees, then here we would be using 360. So h is our phase shift, which is responsible for moving it left and right. And then k is our vertical shift, so moving it up or down. So when we are looking at this, since this isn't a grouping symbol, when we take it out, we have to remember to change the sign. Whereas k is not in the grouping symbol, so we would keep whatever sign this is. Okay. And then also notice in this part right here that this is factored. So if it's not factored, then you will need to factor that first before you can get an accurate h value. Okay. And the only difference between our sine and cosine function is what shape we are talking about. Okay. So again, this is just the same thing here with it being labeled. Okay. Now domain is still going to be the same, so that negative infinity to positive infinity. Again, unless we have context, and then we need to adjust our domain to fit whatever context we're talking about. And then now that we're adding in a vertical shift, our range is going to be affected. So to calculate range, we're going to have to take whatever our amplitude is and then minus our k value. Or excuse me, doing that backwards. We have to take whatever that vertical shift is minus the amplitude, and then that vertical shift plus the amplitude. All right, so next we're just going to do a bunch of practice of identifying things from the equation. So remember, amplitude represents a distance, so we always do the positive a value. Period, we are doing 2 pi divided by b, or if it's obvious that it would be in degrees, so like on number 3, for example, we see this 180. This one we would assume that we are in degrees, so this will be 360 divided by our b value. And then the next one is the vertical shift, so that is k, including its sine. The phase shift is h, including its sine. And then the range, we are doing k minus our amplitude, and then k plus the amplitude. Okay. So in 1, 3 is our a, 2/3 is b, pi is h, and 4 is k. So this will be 3. I'm going to skip the period for a second. Vertical shift is 4. The phase shift is positive pi, because we have to do that opposite sign. And then the range, I'm taking my k value, so 4 minus the amplitude. So this will be 1. And then 4 plus my amplitude will be 7. So that means that as we're graphing our sine functions, that wave is going to be between 1 and 7. And then now to get the period, I'm taking my b value and dividing it into 2 pi. So 2 pi divided by 2/3 really means that we're doing 2 pi times 3/2. So then this will be 6 pi over 2, which we would then simplify to be 3 pi over 2. All right, so again, I would like you to pause the video and then work on answering the next 5 questions that you see. All right, so I'm just going to go through and I'm going to write all the amplitudes first. So again, that is the positive version of my A. So this is 2, here it's 1. So remember, anytime we don't see A or B, because it's multiplication, we assume that it's 1. If we don't see our K value or where the H would be, then we would assume it's 0 because we would be adding. Okay. So this is 1. Let's see, 5 and 1. Now on this one, my K value is over here, so this is not in the correct order. So we have to make sure that we're also paying attention to that. So your amplitude is always a number being multiplied to your sine or cosine function. Okay. All right, so next I'm going to go through, I'm just going to write all of the vertical shifts. So that's the K value. So this one will be -2, 0, 1/2, -2, and 3. And then once we have our vertical shift and our amplitude, we can find the range next. So I'm going to go through and find those. So remember, we're doing K minus amplitude. So this will be -4, and then K plus the amplitude. So this will be -1 to 1. And then 1/2 minus 1 is a -1/2. And then 1/2 plus 1 is 3.5. So for this one, because it would be a nice decimal, you can write your answer in decimal, but just make sure both of them are in decimals, or you can leave them as fractions. And they do need to be in proper fractions instead of mixed numbers. Okay. And then this one will be -7 to 3. And then the last one will be 2 to 4 for the range. All right, so next I am going to work on answering the phase shift. So that is my H. So that's going to be what's being added or subtracted inside the parenthesis. And remember, if this is not in factored form, we need to factor first before we can accurately identify the phase shift. So this one is factored, so it's the opposite of this sign. So this will be -π/2. And then 3 is factored, so 180. 4 is not factored, so I'm going to need to factor out the 3 first. So this will be x, let's see here, -45. And again, to factor, I'm just taking whatever this number is divided by that number in front of x. So even if it doesn't divide nicely, that's what we have to factor out every single time. And then that means for the phase shift, this would be a +45. 5 is factored, and so is 6, so I can just write my phase shift for those. So this will be -π, and then since I don't have anything being added or subtracted here, that means that my phase shift is 0 for this one. And then now I'm going to go back and write the period. So we're assuming that we're in radians unless it's obvious that we're not. So this one, my b value is 1/2. So this means I'm doing 2π divided by 1/2. So 2π times 2/1. So this will be 4π. And we're doing, so this one is in degrees because of that 180. So that means that this will be 360 divided by 1, which is my b value. So 360 degrees. And then on 4, we are in degrees because of that 45 and that 135. So I'm using 3 as my b value. So 360 divided by 3 will be 120 degrees. 5 is factored, so my b is 1. So this is 2π. So again, I'm taking that 2π divided by b. And b is also 1 on number 6, so this will be 2π for the period. All right, so next 6, again, go ahead and pause the video and then work on answering these 6 questions. All right, so just like last time, first thing I'm going to do is I'm going to go through and just write all of the amplitudes. And remember, if we don't see that, we assume that it's a 1 since it's multiplication, and this should always be a positive number. Okay. Next, I'm going to go through and write my vertical shift. So that's our k value. So if that number is not there, we are assuming that it's a plus 0 since we're dealing with addition. So 0, -5, and we're keeping the sign. And then once I have my amplitude and my vertical shift, I can write the range. So it's our k value minus amplitude, k value plus the amplitude. And we can use decimals instead of fractions as long as they are nice decimals. And 8, let's see, -5 minus 8 is -13. -5 plus 8 is 3. And then 0 minus 3, 0 plus 3. 7 minus 2 is 5, 7 plus 2 is 9. -2 minus 2 is -4, and -2 plus 2 is 0. All right, so next I'm going to work on my phase shift, so that's my h. But remember, if it's not factored, then we're going to have to factor first. So as I'm looking at these, so 7, 8, 9, and 10, we're going to have to factor all of those. So I'm going to jump to 11 and 12. So again, I don't have anything being added or subtracted on the inside here. So that means that I can just, we're assuming that it's 0. So my phase shift is 0 for this one and for the next one, since I don't have anything being added or subtracted in there. Okay. All right, now before I can find the phase shift for the rest, I'm going to have to do that factoring step. So for this one, we have to factor out a 2 because that's what's in front of our x value. So when we do that, we're taking whatever this number is divided by the number in front. So this will be pi over 2 divided by 2, which means that I'm really doing pi over 2 times 1/2. So this is going to give me pi over 4. So that means that my phase shift will be positive pi over 4. And then to find the period, we are taking 2 pi divided by our b value, so that's this 2. So that means that my 2's cancel, and I'm left with pi for the period for that first one. All right, so next one, we'll have to factor out the 3. So if I take pi and divide it by 3, that's just going to be 1/3 pi, so pi over 3. So my phase shift will be negative pi over 3. And then to calculate the period, I am taking 2 pi divided by my b value, which is 3, and I can't simplify that. So I'm just going to leave it as 2 pi over 3. All right, next one. We will have to factor out 4/3. So that means that I have to take 1/2 divided by 4/3, which means I'm really doing 1/2 times 3 over 4. So if I simplify, this will be 3 over 8. So that means my phase shift will be a positive 3 over 8. And then to calculate the period, we are taking 2 pi divided by our b value, which is this 4/3. So that means that I'm really doing 2 pi times 3 over 4. So this will be 6 pi over 4, which I would simplify down to 3 pi over 2. All right, next one, we are factoring out 3/2. So I am taking pi over 4, dividing it by 3 over 2. So that means that we're doing pi over 4 times 2/3. So this will give me 2 pi over 12, which would then simplify to be pi over 6. So my phase shift will be negative pi over 6. And then to calculate the period, I am taking 2 pi divided by b, which is at 3 over 2. So this means that I'm doing 2 pi times 2/3, which is 4 pi over 3. And then on those last two, we just need to finish calculating the period for each of these. So again, we assume radians unless it's obvious that it's degrees. So this will be 2 pi divided by 3, which I can't simplify. And then this will be 2 pi divided by 2/3. So this really means 2 pi times 3 over 2. So this will give me 6 pi over 2, which would simplify to be 3 pi for the period. All right, in our next video, we're going to talk about how to take these ideas and then apply them to making graphs.